Hello everyone, welcome again. This is Mr. Scholl, and what we are going to do in this video is we are going to see how we can use Desmos to solve systems of linear equations. We've been doing that in class. So the first thing I want to do with you guys is just very quickly solve a system of linear equations algebraically as we've been doing. So we've got this here. I see that I have an expression for y equals this, y equals this. Therefore, I know that these two are equal. So what I'm going to do is substitute the expression for y from 1 into 2, and I get this expression there. So as you can see, this here is up here, this here is here. To get rid of this fraction, like I've said here, I multiply by 3. Every term here is multiplied by 3. And then I simply solve for x, and I find that x is negative 1. To find my y value, I substitute negative 1 back into one of these two original equations here. I find that 1 is easier to substitute back into, so I do that, and I solve for y, and I find that y is negative 3. Therefore, the solution is negative 1, negative 3. Now we do this in class and we know the steps, but sometimes we don't always stop and think, what is it I'm actually doing here? What I have here is two lines. And what I'm going to show you is what this represents. So if I go here and I'm going to go into Desmos here, I'm going to retype those linear equations. So I've got y equals 2x minus 1. And that's that line that just came up there. My second line that I did in that little example is 1/3 x minus 8 over 3. And that's what I have here. So you can see here, as I pointed out earlier, the interesting points on the lines are often highlighted. In this case, in the orange line here that I have, you can see here the x and y intercepts are highlighted, but also we have a point of intersection that's highlighted. It's identified that as negative 1, negative 3. Okay? Now if we go back here, we saw that the solution is negative 1, negative 3. What we are actually doing is algebraically finding where these two lines intersect if we draw it out. And that's what I've shown here. And this is a way of checking your answer. If you work through your answer and you get something different than negative 1, negative 3, and you type in these equations here into your Desmos, you can actually find out if you're right or wrong. If this answer here, where they intersect, corresponds with the answer you work out here, then you've done your equation right. And I'm going to do one more example here. This is an example straight from class when we first looked at how we solve systems of linear equations that have fractions involved. So if I do x over 3 minus y over 6 equals 1 over 2. And the second one I'm going to do that again, this is straight from class. We went through this together as a class, and we looked at how to do this. If you want to see algebraically how to do this, I suggest you simply review your notes. I'm not going to go over that again. But what we found when we did this algebraically was that the solution was this here. The solution was x is 1, y is negative 1. So 1 and negative 1. And again, these two things here don't look like your stereotypical equations of lines, but they are. We have an x and a y. We have an x and a y here. These are lines, just arranged differently. This app can then wrap it and tell us where it intersects. So you can graph any line that's given in any form. You can go through and solve it algebraically. Easily check your answer to see if that's the correct one. Okay, and that's what I have here. You can see I typed that out, and as we found out, our solution for class was that, which corresponds very nicely with the graph here.